All right there, kids. Let's do a quick review of what you can expect on Tuesday's transformation test. I just want to let you know, as far as the review problems go, they start on page 51 of your review packet, and we have plenty of questions for you. We have what looks like 34 questions, and then starting on page 59 are all the practice with constructions that you can expect, and then right after page 60, we have put our answers with the work on there. All right, so that's where you can find all your review problems. There are no review problems I'm suggesting this unit out of the textbook. It is all out of the back of your packet. All right, so let's start here. Reflect the 19 questions, 51 points. You guys will have plenty of scrap graph paper if you need it. Let's first start with reflections. Reflections through a line. So let's go over different lines that you're going to be responsible for. And at any time, I'm going to go fast here, so you don't have to watch as much. But if you need to rewind, pause it to write stuff down, feel free. As far as reflections go, line reflections, you got the y and the x-axes you got to flip over. You have any vertical line, which is x equals a number. You have any horizontal line, which is y equals a number. You have the line y equals x. And you also have the line y equals negative x. Remember, for y equals x, you flip the coordinates. For y equals negative x, you flip the coordinates and change the sign. All right, so those are the lines you're going to be reflecting over. If you remember on your quiz, I had a line in the fashion of y equals 2x minus 3. Don't waste your time. Don't worry about reflecting over that type of line this time around. You have point reflection. I could go through any point. Okay, the origin, a random point. Remember, for point reflection, you want to use the slope. So if you go over 3 down 2, from that point, you go over 3 down 2. All right, you match the slope on each side of that point for point reflections. Find the line of reflection. This is something I did not put on the quiz, but it's one of those honors reflections. I believe it was day 2 that we did. All right, I will give you A as a coordinate. I'm just making this up. I'm not going to do this, and I'll give you A prime, negative 5, 6, and you have to find the line of reflection between them. And it's not going to be as easy as a vertical line, or a horizontal line. All right, it's going to be one of the type like y equals 2x minus 3, but you are responsible for that. Easiest way I can put this, guys, is you take these 2 points, connect them using a straight edge to form a segment, and then you find the perpendicular bisector. So find the midpoint, find the negative reciprocal for the slope, plug it into y equals mx plus b to find the y-intercept. All right, so that I can definitely guarantee will be on there. So that's as far as reflections go, that's it. Let's move on to translations. Make sure you know the difference between function and vector. Again, let's just quick review. Function notation for translations. I have x comma y implies x, whatever you did to the x value. So I'll just say minus 4, y plus 2. If you take a look back at your quiz, those were on your quiz. Just take a quick peek here. I'm talking about question number 8, A, B, and C on your quiz. So if you wrote those in the wrong notation, learn from your mistake. You also have vector notation for a translation. So if I was to put this function notation into vector, it would just be minus 4 plus 2. All right, please remember, when you move left and right, that's the first number that goes in there. Some of you guys on your quiz, you went up or down first, and that's the number you put first. No, the left and right number is the one you put first on the x-axis, all right? And also, just like I had on number 8 on your quiz, you might have to find that translation rule for me and write it for me. Rotations. Here's what I'm looking for as far as rotations are concerned. I'm not going to get crazy. You could go 90, 180, or 270 for me. You guys that don't turn the paper and maybe memorize the rules, here you go. Rotation of 90, xy turns into negative yx. When you rotate 180, xy becomes negative x, negative y. And for 270, xy becomes y negative x. So you guys that memorize the rotation rules, there they are. You guys that don't and turn your paper, just make sure you turn it in either clockwise or a counterclockwise fashion. Dilations, as you can see, guys, I didn't put anything here under dilations. We just did them yesterday, so hopefully that's pretty fresh in your mind. I'm going to ask you to dilate a figure, maybe find the scale factor. Nothing too crazy with dilations, all right? But just make sure you look over those, especially those multiple choice questions where you may be dilating a line. If the center of dilation is on the line, the new line, the image is the same as the pre-image, right? If the center of rotation is on the line. Compositions, if you remember what I mean by composition, so I'll do a capital R of 90, there's that composition symbol, and I'll do a little lowercase r with the y-axis. Remember, these are done right to left, excuse me, they are done right to left. So the first thing that you guys would do would be a reflection through the y-axis. So this would be done first. And then whatever point you got from there, you would rotate at 90 degrees. All right, so that's what to remember for compositions. Symmetry. All right, we have our line symmetry where you can draw a line down, flip it over, and it matches right up. Point symmetry, remember, is you flip an object upside down, and it is that same object you started with. For instance, if we just, a simple example, letters of the alphabet that have point symmetry. All right, you can take X, I, and I'm not going to go through all of them, but those have point symmetry because if you rotate them 100, I'll add S in there. If you rotate them 180 degrees, aka upside down, they're the same letters I started with. So when a rotation of 180, it maps itself. All right. So point symmetry, rotational symmetry. All right. Quick example. Let me get my regular pentagon out here. All right. Here's my regular pentagon. All sides and angles are congruent. All right. This does have rotational symmetry. Rotational symmetry, you can rotate an object 180 or less and get that same figure back, right? This does have rotational symmetry. With that, I may ask you tomorrow for the order. The order is how many times, if I turn this figure all the way around, how many times do I see that hexagon from 0 to 360? All right, and I would be able to see it that pentagon 5 different times. So the order would be 5 for that pentagon. The other vocabulary term I could ask off that is the magnitude, which is the smallest degree measure to rotate this. So here you go. If I go from here, get out of there. Okay, if I go from here to here, how many degrees did I go? I can take 360 and divide it by the order. 360 divided by 5, I went 72 degrees. All right, quick little question there, honors kids. How many degrees do I go from this vertex, hey, to that vertex right there? All right, take a second to think about it. Pause the video if you want. Well, from this vertex to this vertex, I went 72 degrees. That's the minimum number. So I'm going to go another 72 degrees for a total of 144. All right, so just a little checkup question there. Not finally, but you do have your constructions. Look, guys, I put all of them on Aspen under the transformation folder. They're all up there. You can always go back and look. I'm going to tell you, you're going to probably have 3 of them on the test. All right, in some fashion or another, you're going to have at least 3 of them. Reflection, given a line, reflect it over the line. If I give you 2 figures that have been reflected, can you guys construct where that line of reflection is? All right, go back, look at the videos. It's up there. Look at your notes. Can you guys rotate a figure 90 or 180, 90 degrees or 180? Can you find the center of rotation given 2 figures? Translation given a vector, and then what we did yesterday, which is dilation given a scale factor. All right, might be one. I'm not going to go crazy. Just make sure you're aware of a dilation if the scale factor is 1/2 or 2. All right, I'm not going to get any crazier than that. But at least somehow 3 of those constructions are going to appear somewhere on Tuesday's test. And those are also in the back of your packet if you need some practice. And finally, prove two triangles are congruent using rigid motions. That's what we did on Wednesday in class, where you find out what you're doing. So if you're doing a reflection, it's a reflection through the x-axis. Reflections are rigid motions, which preserve distance and angle measure. Therefore, thus, henceforth, whatever word you'd like, the triangles are congruent. You also have a couple of those I put on there in the review section: 34, 33, 32, geez, 31. There you go. Okay, they're all different using rigid motions to prove the triangles or figures congruent. All right. So now what you'll do from here, you're going to stay right where you are in your groups, and you're just going to get after it. All right. Look back at the videos if you want, if you're going to do constructions, or go somewhere in your packet and keep reviewing. I'll answer any questions that you have quickly on Monday. Again, as you guys know, Monday we're going to start the new unit, and then Tuesday will be the transformation test. All right, so go ahead and get going.